Dear 11th standard students, in previous video session, you gained knowledge about motion of two bodies in contact with each other. When two bodies in contact, then the two bodies are placed on a smooth frictionless horizontal surface. We apply the force acting on the object, then both the objects set into acceleration with the common acceleration. And also, your awareness about contact force between two bodies. Contact force exerted by the first body on the second body, and also contact force exerted by second body on the first body. You have knowledge about these kind of topics. Today in this video session, we will discuss about motion of connected bodies. So what is motion of connected bodies? Take two objects connected by a string. After connected by a string, then apply the force. After applying the force, then the body is set into acceleration. We are going to calculate acceleration. After connecting the two bodies by a string, tension produced in the string by applying the external force acting on the two bodies. So, depending upon the force, external force acting on the bodies, when the two bodies connected by a string set into acceleration, then acceleration is variable depending upon the external force acting on the two bodies. See the topic, motion of connected bodies. See the diagram, it is one rigid support. It is a pulley. Take one string. Two ends of the string is connected with the two blocks, and the string is passes over on the pulley. See, it is a string, it has a character light string and also inextensible string. It is the block, first block, it is the second block. Mass of the first block M1, mass of the second block M2. In these two blocks are connected at the two ends of the light inextensible string, then passes over on a pulley. So after that, M1 mass of the block experiences gravitational force vertically downward direction. So this is the not only M1 block of the mass, not only M2 block of the mass, any kind of mass experiences gravitational force vertically downward direction. So this is M1 mass experiences gravitational force that gravitational force acts vertically downward direction. M1G. Generally, gravitational force experienced by any object F is equal to M into G. So that's why M1 mass of the block is experiences gravitational force acts vertically downward direction M1G. Then the block experiences gravitational force vertically downward direction, tension produced in the string acting vertically upward direction. Coming to other, M2 mass of the block experiences gravitational force vertically downward direction M2G. Then tension in the string acts vertically upward direction with the same tension T. See, M1 mass, this is the first block, has a mass M1, second block has a mass M2. Both the block is connected with the two end of the light inextensible string which is passes over on a pulley. Then both the block experiences gravitational force acts vertically downward direction. Then due to that gravitational force, tension produced in the string acts vertically upward direction at both the strings. But in the case M1 mass is greater than that of M2 mass. M1 mass is greater than that of M2 mass. This is a condition. These two masses, out of these two masses, M1 mass is greater than that of M2, then the first mass experiences greater gravitational force compared to second mass. Then due to that difference in gravitational force, then the entire whole system is set to accelerate with the same acceleration. Then after the system is released, M1 block of masses experiences greater gravitational force, M2 mass of the block experiences lesser gravitational force. Due to the difference in forces, then the whole system is set into acceleration. Then the M1 mass of the block experiences acceleration vertically downward direction. Due to greater gravitational force, M1 block of the mass moves vertically downward direction with an acceleration A. Then M2 second block has a mass M2, experiences with the same acceleration but vertically upward direction. Now in our aim to determine what is the acceleration produced on both the blocks, then how we find out the tension produced in the string. We are going to see the further. Before going to that calculating acceleration and tension produced in the string, first we draw the coordinate system. X coordinate and Y coordinate. Origin of the coordinate system. Take this system, it is a first system. This first system we apply the free body diagram, FBD. FBD of mass M1. So the block of mass M1, it is treated as a point mass in the free body diagram. M1. Then represents in the free body diagram what are the forces acting on block of mass M1. First one force, gravitational force acts vertically downward direction. Another force, tension produced in the string acting on the block M1 acting vertically upward direction. We represents there are two forces acting on the block of mass M1. So the block of mass M1 is treated as a point object. The gravitational force experienced by the block of mass M1 acts vertically in downward direction, M1G. Then tension in the string acts vertically upward direction on M1 mass. It is T. Then we apply the Newton's second law of motion on the block of mass M1. We apply the Newton's second law of motion to the block of mass M1. We know that Newton's second law, net force acting on the system, which is equal to ma vector. Generally F is equal to ma. In vector notation, net force or total force acting on the system, F net force, which is equal to m a vector. A vector is the acceleration, where m is the mass of the block, a is the acceleration of the block. F net means net force acting on the block. See, in the first case, block of mass m1, what is the net force acting on the system? How to find out? One force, gravitational force, acts vertically in downward direction. Another force, tension produced in the string acting on the block of mass m1, act vertically upward direction. Gravitational force acts vertically in downward direction. m1 into g. m1 into g. In vector notation, that force acts downward direction, which is negative y-axis. This is downward direction is taken as negative y-axis. Upward direction, positive y-axis. So therefore, m1 into g, negative y-axis minus j cap, plus tension produced in the string acting on the mass of block m1 vertically upward direction along the positive y-axis. So unit vector j cap, the tension T, j cap, which is equal to mass of the block m1, acceleration of the block of mass m1 acts vertically downward direction. Then m1 block of the mass accelerates vertically downward direction towards the negative y-axis, a minus j cap. So m1g minus j cap plus t j cap, which is equal to minus m1a j cap. Rearrange this equation. T j cap minus m1g j cap, which is equal to minus m1a j cap. Equation number 1. This equation 1 is multiplied with the negative sign on the both the direction, minus t j cap minus m1g j cap, which is equal to minus m1a j cap. So minus t j cap plus m1g j cap, which is equal to m1 a j cap. So m1 g j cap minus t j cap, which is equal to m1 a j cap. Equation number 2. Now, equation 2, comparing the components of y direction. Comparing the components along y direction. So, m1g minus t, which is equal to m1a, equation number 3. We find equation 3 by comparing the components along the y direction, j cap, j cap, j cap. So m1g j cap minus t j cap, which is equal to m1a j cap. So after comparing the components along the y direction, we get the equation m1g minus t, which is equal to m1a. So we found the equation m1g minus t, which is equal to m1 into a. Then coming to other side, in the mass of block M2 experiences two kind of force. One is gravitational force acts vertically downward direction, and the tension in the string acts vertically upward direction acting on the mass of block M2. Out of these two, tension force is greater than that of gravitational force experienced by the mass M2. That's why then the M2 block of mass is set into accelerates vertically upward direction. We see the free body diagram for block of mass M2. So, block of mass M2 is treated as a point mass in the free body diagram. Then, draw the what kind of force is experienced by the block of mass M2. First one, gravitational force experienced by the block of mass M2 is vertically downward direction M2 into G. Then tension in the string acting on the block of mass M2 is vertically upward direction. Then out of these two forces, imbalanced forces, tension force is greater and gravitational force is lesser, then the block of mass M2 is set into acceleration with the vertically upward direction. Now, we apply the Newton's second law of motion for block of mass M2. Net force acting on the block, which is equal to m into a vector. What are the net forces acting on the block of mass M2? First one, force. Tension force is greater force. The tension force is acting on the block of mass M2 is vertically upward direction along the positive y-axis. So T j cap plus. Then gravitational force acting on the block of mass M2 act vertically downward direction. M2G, downward direction means negative y direction, minus j cap, which is equal to mass of the block M2. Acceleration of the block of mass M2 is acts vertically upward direction along the positive y axis. A j cap. So T j cap minus M2 G j cap, which is equal to M2 A j cap. Next, by comparing the components along the y direction, along the y direction, T minus M2G, which is equal to M2A. This is equation number 4. See, equation number 4 and equation number 3, both the equation is added together. T minus M2G, which is equal to M2A. Equation 4 and equation 3 adding T minus M2G, which is equal to M2A, then equation 3 M1G minus T, which is equal to M1A. So T minus T add with each other 0, then M1G minus M2G, which is equal to, add these two, M1A plus M2A. So M1G minus M2G, G take common out, M1 minus M2 into G, which is equal to, acceleration of the both the block is the same acceleration taken out commonly, A, M1 plus M2. So acceleration of the both the block with the same acceleration A, which is equal to M1 minus M2 into G divided by M1 plus M2. This is very important expression when the bodies connected by a string passing over on a pulley, due to the force experienced by the blocks, then both the blocks set into accelerate with the common acceleration A is equal to M1 minus M2 into G divided by M1 plus M2. So see the students, this expression, acceleration of the both the block, both M1 mass of the block, another block of mass M2, both the block is set into accelerate with that same magnitude of acceleration. That's important. M1 block of the mass is set into accelerates vertically downward direction towards negative y-axis, but M2, that second block of mass M2, is set into accelerate with the same acceleration towards positive y-axis, but both the block of mass setting to accelerate with the same magnitude of acceleration with a different direction. So this expression gives only magnitude of acceleration experienced by both the blocks. But in vector notation, acceleration of block of mass M1. In vector notation, A vector, which is equal to M1 minus M2 divided by M1 plus M2 into G towards the negative y-axis. It gives the unit vector minus j cap. So A vector, which is equal to minus m1 m2 divided by m1 plus m2 into j cap. Second one, acceleration of the block of mass m2 along the positive y-axis. In vector notation, A vector, which is equal to m1 minus m2 divided by m1 plus m2 into g, but that acceleration direction along the positive y-axis, it gives the direction by the unit vector j cap. So this is the very important vector notation. Acceleration experienced by the block of mass m1. This is the second expression. Acceleration is experienced by the block of mass m2. Next, an important thing, m1 mass is greater mass, m2 mass is lesser mass. So m1 mass is experiences greater gravitational force, m2 mass is experiences lesser gravitational force, but both the block of mass m1 and m2 is connected with the two ends of the same string. That's why tension produced in the string in either direction with the same magnitude. We are going to calculate the tension produced in the string. How to calculate tension produced in the string? We choose any one equation. See equation 3, m1 into g minus t, which is equal to m1 into a. From this equation, we substitute acceleration of both the block system. We get the tension produced in the string. We choose the equation 3. m1 into g minus t, which is equal to m1 into a. This is equation 3. We know that the acceleration a is equal to m1 minus m2 divided by m1 plus m2 into g. So this acceleration equation is substitute in equation 3. m1g minus t, which is equal to m1 acceleration m1 minus m2 divided by m1 plus m2 into g. So m1g minus t, m1g into m1 minus m2 divided by m1 plus m2. So in our aim to determine the tension in the string, so therefore rearrange this equation m1g, this term coming this side minus m1g, m1 minus m2 divided by m1 plus m2, t, which is equal to t positive. So from that equation, M1G minus M1G in this term which is equal to tension in the string, M1G take commonly out. M1G 1 minus M1 minus M2 divided by M1 plus M2, which is equal to T. So M1G M1 plus M2 minus M1 plus M2 divided by M1 plus M2, which is equal to T. M1 minus M1 get cancelled with each other. Then M1G into 2M2 divided by M1 plus M2, which is equal to tension in the string. So tension produced in the string 2 M1 M2 divided by M1 plus M2 into G. This is another important expression. When the two blocks connected by a light inextensible string that passes over on a pulley, how to calculate tension produced in the string by the expression T is equal to 2 M1 M2 divided by M1 plus M2 into G. So see, this can be applicable. M1 mass is greater than that of M2 mass. We can lift the M2 mass by the M1 mass, because M1 mass is a greater mass, experiences greater gravitational force. M2 mass is experiences lesser gravitational force. So therefore these two difference in masses experiences different gravitational force. M2 mass is lift by an greater gravitational force experienced by the M1 mass. And also, what happens if two masses are equal? What happens in the whole system? That is the another one case. We know that the acceleration of the system A is equal to M1 minus M2 divided by M1 plus M2 into G. That is the magnitude of acceleration experienced by both the block. But in that case, both the block has the same mass, means both the block experiences same magnitude of gravitational force. There is no difference in gravitational force. So net force acting on the system is 0. So therefore, then the whole system is at rest position. It can be represented in that equation M1 which is equal to M2. Both the block has the same mass, M1 mass which is equal to M2. So therefore A is equal to M1 minus M2 also M1 because same mass divided by M1 plus M2 into G. So A is equal to M1 minus M1 0 divided by M1 plus M2 into G. Then acceleration of the whole system is 0. Then the whole system is set at the rest position. So in this video session, see motion of connected bodies. In that motion of connected bodies, both the block is connected by a light inextensible string. Then both the block is set to accelerate with the same acceleration. Already we found. Then tension produced in the string. This kind of motion is said to be vertical motion of the block. This is vertical motion. If both the block, M1 mass of the block is setting to accelerates along the vertically downward direction, that is the vertical motion. M2 block of the mass is setting to accelerate with the vertically upward direction, it is also vertical motion. So both the block is connected by a light inextensible string passes over on a pulley, then both the block as a different in mass experiences different gravitational force setting to accelerate. We found the acceleration expression, we found tension produced in the string. So next class we will discuss about motion of the block in horizontal direction. We will see later. Thank you.